Alright, dudes and dudettes. Had a misfortune a minute ago and dropped a perfectly good 6v6 tube on the floor and busted it. So I thought I would make the most of it and make a video of the guts of 6v6, and also we'll have just a general discussion about 6v6s and maybe even some substitutes for 6v6s. First thing I thought we might do with this one that's been broken is disassemble it completely here, and just take a look at the components and see how one of these things is put together. It's not every day you probably see the internals of a tube and get a chance to discuss that. So that's what I thought we might do here. This little top piece right here that holds everything together, they call these a mica. That's M-I-C-A. Looks like it has a couple of little tiny rivet-like structures here that hold the mica on. We're going to get some pliers, remove that, remove the mica, and take a look at some of the components. Okay, first things first here. Let's get rid of the rest of the glass around this tube. It can be easier said than done. That's some tough glass. I mean, I've dropped tubes before and didn't have them break. I've got a particularly hard floor that I'm on now, and they tend to break on this floor. I've actually broken more tubes lately than I think I've broken an entire rest of my life. Like the past couple weeks, I've broken a shit ton of tubes. But yeah, this is what the tube looks like, and you can get a better look at all the structures here. Let's see if we can get these little pins off. This might be somewhat difficult because, let's see, I'm just going to try to pry these off of here. I think my battery on this phone's about to die, so I may have to come back after we get a charge on it. Okay, I've taken those winged pieces off. And let's see, that piece right there is bent over. That might have been done in the fall off of the off the disc. This should come right up off of there. That's how it's assembled. There we go. And you can see it's kind of cracking. It's not even like a real thick metal. It's almost like a plied metal. You can see the mica itself is made of multiple plies. Look at that. Or shoot, I'm not even on the screen. But see the mica? It's like it's made of multiple plies. Weird. They're very thin pieces of, I don't know, is that plastic? I always assumed the mica was metal, but yeah, it couldn't be metal, because then it would conduct to all of the components. So yeah, it can't be metal. It's like a little plastic. Duh. Now that I think about it, it's a pretty stupid assumption on my part to think that a mica would be metal. But yeah, that's what it is. It's like a clear plastic. It's made of multiple plies. So there's the mica off. Let's see. You can see the grid. That's the thing in there that actually looks like a grid. Let's see if we can hone in on that a little better. There we go. Better shot of it. You can see those multiple strands of wire. That's the grid. That's where your signal comes into the tube. And the thing that's in the middle, that's going to be your heater. And the cathode, there's actually 3 grids in this thing, but that's one of them. Let's see. How does the plate come off? I think the plate actually wraps around on the edges right here. I think it's actually crimped in. So let's see if we can find a spot there to pry. Let's see. Almost need something thin to get in there, don't I? But yeah, see, you can see these little these little welding points right there. See the little 4 welding points where it kind of was assembled in the factory. Okay. Yeah, let's get in here after this. I don't know if you can see what I'm doing. I'm kind of just getting in here and prying this off. This is the plate. This whole outer piece is the plate. And this is the part of the tube that sends the signal after it's been amplified by the tube onward to the next stage. In this case, it would be the output transformer, and then onto the speaker. But yeah, you see there, managed to pop that loose. There we go. So we can pry that open and see inside of it. So this is a sight that you don't see very much inside of a 6v6. Let's get the other side off of the other side of the plate off, and then we can disassemble it further. Alright, let's pry this off of here. This would be like trying to pry my wife out of a store I don't want to be in. Speaking of which, I can't stand going to the mall. Am I alone in this, men? I mean, I'm sorry if I have some ladies watching as well and you like going to the mall, but you're wrong. The mall sucks. Especially ones without music stores in them. At least if it has a music store in it, you know, or a Radio Shack maybe. I mean, Radio Shack's not so much, but a music store, you know, at least I've got somewhere to go and hang out. But my wife will be in a fucking mall. And I try and try and try, but cannot pry her out of the mall. So what you end up doing is you end up sitting on a chair somewhere. Just, you know, what else are you gonna do but maybe go to sleep? But anyway, here is the okay, let's take a look here. Alright, inside this piece right here, this is the piece that lights up, otherwise known as the filament. Let's get a better look at it. That piece right there is the filament, and that heats up, and when it does, it heats up the cathode. And actually, the cathode and the filament are in that same piece together, I believe, if I'm not mistaken on how a 6v6 is constructed. So yeah, the filament's actually inside there. So when it heats up the cathode, which is also part of this structure. And you can see the 2 leads coming off down here for the filament. There's another lead that comes off as well. But one of these will be for the cathode. See right down here, see these 2 leads coming out? And there's a third lead leading off over here. So let's see. So yeah, one of those will be the cathode, probably that one, and then these will be the filament leads. The filament goes up in there and probably winds around. It's basically just like a tungsten. I think they're made of tungsten. They might also have some other proprietary metals in there to prolong life, but I think essentially it's tungsten. Some were treated differently, I'm sure, from different manufacturers. But these little grids, you can see them. They're basically just strands of wire that are wrapped around these posts here, and those are your various grids, and those are the control grids that control how many of the electrons that are emitted from this cathode as it gets heated up by the heater, which is inside. How many of those electrons can make it through this grid network to the plate, which we saw on the outside. So that's how a 6v6 works. That's the inside of a 6v6. Now let's talk a little bit about some other tubes that are close to a 6v6 that if you run across them, you can actually use as a replacement for a 6v6. Okay, if you watch some of my other videos, you probably have seen the one where I show the big lot of estate auction finds that I got the other day. Well, this was one of the things that was in that estate auction that I didn't get around to showing before. And this is actually one of my favorite little pieces from all of that stuff that I got, and I completely forgot to show it. But this is an old tongue sole book. It shows all of the tube base connections, and of course all this same information is in the RCA manual also, which I also have. But I like this a lot because it's thumb size, you know, it's tiny, and it shows all the base connectors. But it's got a little table of contents. This thing was printed in 1953 by Tongue Sole Electronics, Newark, New Jersey. Reference book of base diagrams may be used conveniently while repairing a radio or television set, or an amplifier in our case. Diagrams are located easily, pages blah 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 blah. And yeah, that's kind of cool because see, it's flat, it'll stay open. So I like this. Unlike my copy of the RCA tube manual, I would have to break the spine to get it to stay open. But yeah, I've used this thing a lot. I love this little book. How cool is this? But yeah, let's look at the 6v6 in our table of contents. 6v6, page 51. So 51, here we go. Okay. This is going to be all of the stuff, all the different tubes that can be substituted for 6v6, at least the main ones that they'll have listed here. There are others as well, and we will take a look. But obviously, we have the 6L6G, 6L6GA, 6U6, which is one you don't hear a whole lot about, and we're going to talk about that one in a minute. The 6W6. Let's see what else. These are all 12 and 25 volters. There's a 35 volter. A lot of those are used in the series filament amplifiers. The 5881, of course. The 50L6 is used a lot in the series amplifiers. A 5932, a 5992, 6046. See, all these have the same pinout. That doesn't mean that they're drop-in replacements, all of them, but it means that they have the same pinout. Obviously, we can't use the ones with the higher voltages, you know, the 12 volts or the 35 volts, because they just simply wouldn't work. They probably wouldn't burn up if you were to drop them in, but I don't think that they would work at all. So let's look at the ones that might work. For instance, let's look at the 6U6 and the 6W6 for starters, and then we might also look up the 5932, 5992, and the 6046 and see what those are. The 1622 is just that's like another name for 6L6. I do know that. So, you know, these other numbers that I don't recognize, they might be actually like military numbers for some of these tubes. I do know that 1622 is. But we'll cross-reference this with the with the RCA manual as well. But we're going to write down 6U6, 6W6 for sure, and the 6Y6, which I almost forgot to mention. So let's look at those three for starters. The U6, W6, and the Y6. I'm going to see if I've got a couple of those to dig out. Okay, here's a bunch of tubes that I also got in that recent lot that I really didn't even bother to show. I didn't even bother to show all the tubes. There's just so many of them. It would have taken me a while to even pull all that shit out. But yeah, what did I say? The 6U6. So let's see if we got some 6U6s. I think I saw one. There we go. There's one right there, a 6U6. So let's grab one of those. And let's also grab a 6W6. I see a bunch of those too. So a 6W6, that has the same pinout for sure. You'll notice there are some other ones here as well. But let's see, what was our third one we noticed? The U, the W, and the Y. A 6Y6. Did I see a 6Y6? Let's see. Tell me if you see one. Okay. Well, I don't see one. I don't see a 6Y. I probably have one. I just don't have one in this batch of stuff. There's a 6H6. And that was the next thing I was going to say. You'll notice that there are some other letters that are sandwiched in between two sixes here. Actually, whoa. 6Y6 right there. Bam. 6Y6. So I do have a six. I do have all three of those. But I was going to say, you know, you'll notice there's some other tubes here that have letters sandwiched in between two sixes. The first 6, you know, obviously means the voltage of the filament. The last 6 means the number of connections, basically, that's inside the tube. The H could denote that this is a different pinout. And what we can actually do is we can look up the 6H6 in our little book here. Let's see if it's a different pinout, just out of curiosity. Alright, 6. Let's see, N, K, 6J6, 6J6. Let's see if there's a 6H6 in here. Apparently I've forgotten my alphabet. There it is. Page 61. So it's definitely going to be a different pinout. 6H6. And actually it's a completely different tube altogether. Look at that. So just because it's similar does not mean it's going to be similar. Look at this. This is a dual triode. 6H6 dual triode. Interesting. So if I tried to pop that in a 6V6, it would probably you'd probably see some smoke. See the difference? That's a pentode. That's a dual triode. So that would cause some problems. We have a 6K6 here as well, which intrigues me because I have quite a lot of those. Not just in this box, but in others as well. So 6K6. Let me look at that one. See if it's in here. It should be. Because that tube looks as old as the rest of them, from the same era as this book. Let's see, 6K6, right there, page 63. Alright, 63. Alright, actually this one also has the 6F6, 6M6, 1621, let's see, 6G6, 6K6. So yeah, a lot of these other ones that are in this box will be this type as well. And this is a pentode, so it's similar to the 6V6, but let's see in what ways it's different. The number 1 pin, first of all, is connected to the shield, but in the 6V6, let's see, we can flip back and forth, there's no connection. Okay, so shield, no connection. The second one is a heater. That's a heater. The plate is number 3. Grid 2 is number 4. Grid 1 is number 5. Okay. Over here, pin 7 is a heater, and pin 7 is a heater. Pin 8 is a cathode. So, interestingly enough, the no connection is the only difference. And that shield is like the outside of the tube. So a 6F6 is probably going to be a, even though it doesn't have the same base, it is a drop-in replacement. So there's two lessons at work here. Just because you see, you see two numbers and a couple letters sandwiched in between, and they happen to be real close, doesn't mean it's a drop-in replacement. But also, just because two tubes have different pinouts in the book doesn't mean that it's not going to be a drop-in replacement, because it might be something simple like what we just saw. Now this should be again, yep, you see there, that's a this is the shield, this outer case, just the whole thing. This is what that will connect to. In the other, there's no connection. In this one, it's connected to the shield. So this will be a drop-in replacement for a 6V6. And so will a 6M6. So will a 6F6. So let's get an F. This is actually a 6F6. So let's get this 6F6 out. So there's that. Let's get a 6G6 as well, because that one should be also. Do I see a 6G6? Let me see. There's a 6K. There's plenty of 6K6, so I'm going to grab a 6K6 as well. Alright, so all these will be drop-in replacements. Let me see. Let's get. What am I missing? The G6. 6G6. And you see one? This isn't all of my six tubes, but I think the G6 is the only one that I don't have here by the look of it. So what I want to do here, and let's see, let's check these actually. Well, that one won't be because it's not doesn't have a shield. Yeah, that's not going to be one. Let's check. We have plenty to go on for giggles here. We have 5 different tubes: a 6U6, a 6Y6, a 6W6, a 6F6, and a 6K6. Now all of these are going to have different gain structures. They're going to have some different filament draws and things like that, I'm sure, which will prevent them from being drop-in replacements for all amplifiers. So we want to make sure that everybody understands that. Don't just go drop one of these in an amplifier and assume it's going to work. Do your research first, or at least stick around through the end of this video and let's look at the book together. Okay, I cross-reference the pinouts with the RCA receiving tube manual and came up with some more options here. But let's go down the list of the tubes that match a 6V6 in terms of pinout. Obviously we have the 6V6. The next down we have a 6W6, which we've already discussed. It's pretty close in terms of plate voltage. Maximum dissipation is fairly close. Plate current's close. Transconductance is a lot higher. The screen voltage is where it kind of falls down. You would have to do some adjusting, some modifications to your amplifier circuit probably in order to make this work. What you may be able to do is come off of the node that's driving your preamp tubes maybe, and drive your screen off of that, and that might get it a lot closer, but it's probably not worth screwing with a 6W6. Moving down, 6K6, we have maximum plate voltages that are fairly lower, but not out of the realm of possibility. 8.5 watts of plate dissipation, which is considerably lower, which makes it kind of attractive if you're looking for that bedroom amp. Lower plate current maximums, but that may not be awfully low to make that much of a difference. Lower transconductance, and the screen voltage is still relatively high. It's not that far off from the maximums for the 6V6. And it's certainly not that far off from where a 6V6 typically can run. A 6F6, now this is an attractive tube because we have a higher maximum plate voltage than our 6V6 did. We have 11 watts of plate dissipation, which is lower, which kind of satisfies that itch to search for a different tone. We have very, very similar maximum plate current, lower transconductance, and very, very similar maximum screen voltage. So the 6F6, I'm going to put a big check mark beside this one because this one is very promising. That is one that we will, if you find any 6F6s, you know, if you're going through an old, some old guy's, you know, collection of tubes or something, and you want to know which ones would be compatible, a 6F6 is a good candidate for a drop-in replacement for a 6V6. As a matter of fact, it wouldn't scare me one bit to drop one in right now, and probably any of the amps that I have that run 6V6s, and just see how it goes. It's that close. The one other thing that we might want to look at, just to be sure, would be the heater current draw and make sure it's not drawing, you know, significantly higher. But I don't see where that, you know, would be a concern. Most likely. We have a 6Y6. This is an attractive tube also. If you wanted to try to cut costs on your design, you might be able to get away with a transformer with a lot lower voltage output. This one has a 200 volt maximum, but it can squeeze 12.5 watts plate dissipation out of that. That's the maximum it can handle. The plate current is 66 milliamps, so it's higher plate current. Transconductance is also higher. The maximum screen voltage is the same as the plate voltage. But this is a weird and kind of attractive tube. If you want to do some experimental building, that would be kind of a cool tube to screw with. I have, I think, a few of these, and I can't imagine they would be very expensive on the secondary market. You might be able to find tons of NOS 6Y6s out there, and if if you're bold enough to design an amp for that, I mean, you might be onto a winner. 6U6, we have 200 volts also, just like the 6Y6, 12 watts of dissipation. I'm not sure on these figures, and lower 135 volts maximum screen voltage, which makes it less attractive in my book to the 6Y6, but still on the same kind of order. Found a couple more here, a 6EY6, which has a maximum of 250 volts, 11 watts plate dissipation, 250 volts on the screens. I'm not sure about these figures. Here's a 6EZ5, which is very interesting. This one, the RCA manual did not have data for, so I had to look it up. But the data that I found was, I think, a GE data sheet, and it said that this tube was for televisions, like horizontal deflectors, I think. And it runs at 350 volts, just like the 6V6 maximum. 12 volts, which is just a couple, or watts rather, which is a couple watts less on plate dissipation. 43 milliamps, which is also very, very close. Exact same transconductance. 300 volts on the screen, so ever so slightly lower than a 6V6. Very, very similar to a 6V6. As a matter of fact, a 6EZ5, I would venture to say, would be a very good candidate also for a drop-in replacement. I think if I had found one in my stash, I would drop it in a 6V6, and just like the 6F6, it wouldn't concern me a bit. The 6DG6, and again, I will stress though, you want to make sure that your heater current is going to be the same sort of draw. It's not going to draw significantly higher, because if it did, you may risk burning up your 6.3 volt winding. The 6DG6, 200 volts maximum, so we're on the order of this 6Y6 and the 6EU6 up here. 10 watts maximum plate dissipation, which is lower than either of these. 47 milliamps, which is the same as the 6V6. 8,000 on transconductance, which is about the highest one here, other than the 6W6. And 180 volts maximum screen, which is also on the same sort of order as the 6Y6. So if you're going to design something for a 6Y6, your 6G6, or your 6DG6 rather, may be a drop-in substitute for that. The 6G6, this is an old, a very old tube that came out, I think, around the same time as the 6L6s, about 1937. It's a big Coke bottle looking tube, and it took me a minute to find a data sheet on this because it's just an old tube. It's kind of obsolete. 180 volts maximum on the plate, 2.75 watts for all of your effort is your maximum. 15 milliamps of plate current, which is significantly lower than anything here. 2300 on transconductance at 180 volts. So this at least gives you an overview of some of the possible substitutes for 6V6, other than your typical 6L6 or EL34, which you would have to seriously rebias in order to make work. But these may be good drop-in substitutes. The 6EZ5 is extremely close, so close in fact I would almost venture to guess this may be some kind of spin-off tube. Maybe they were making a big batch of 6V6s and they didn't quite come up to spec or something, so they decided to rename it a different tube and, I don't know, slap a design or something out there on the market to get people to use it. It may be a very rare tube. I haven't even looked on eBay to see if there are any of these, but you might check your stash and see if you have any 6EZ5s, because those might be direct drop-ins for 6V6. The 6F6 looks to me like it's probably going to be the most plentiful of all of the 6V6 direct substitutes. So yeah, if you have any 6F6s, or if you run across any at any state sales or any old tube amp guys stash, check those out. And I'll tell you what, let's go ahead and pop in. I do have a 6F6, so let's get a small 6V6 amplifier and just pop one in and see what happens. All right, well, in spite of my best efforts, I could not locate a 6EZ5 anywhere in my stash, so we won't be able to try out a 6EZ5. If anyone else out there has tried a 6EZ5 and a 6V6 amplifier, let me know, and if you have recorded it, post a link to your video in the comments, please. We're going to try a couple different 6F6s, though. I did locate a couple of those. I've got several, I believe. And first we're going to try the normal 6V6 through a 6V6 amplifier. This is an early 50s Magna or Magnatone student amplifier. And you can actually go back through. I'll post a link to the video of the repair for this as well if you're interested in that. But let's check it out with a Telecaster. What it sounds like with the 6V6, and then we'll move to the 6F6. Okay, let's try it with the 6F6. Alright, here we are with the 6F6. This is a Kenrad. This is a metal shield version of the 6F6. I've touched nothing else, and I put the volume right back where it was in the amplifier. Now, ideally, you would want to rebias for the lower plate dissipation of the 6F6, and I'm not doing any of that. I'm just popping the 6F6. But let's now listen to a glass bottle version of the 6F6. Check out this packaging. This thing is huge, huge package. But I found this in my tube stash, so we'll check it out with the glass bottle version as well. But we might as well check out this packaging too. Well, it's pretty cool. This packaging might even be from the 30s or 40s. It's definitely older style. But there's the 6F6G. So let's try this one in there. Okay, here we are with the 6F6G glass bottle version. will say the 6F6 is definitely a little less volume, a little cleaner. I think if you were trying to get this thing to break up at more like a bedroom volume, this might be a cool tube to try, but you might want to adjust the bias accordingly and maybe modify it slightly. But that's going to probably get you a little more breakup at a slightly earlier stage, and it's definitely got a little bit of a cleaner, just overall it has a little bit of a cleaner tone. Okay, I did happen to run across a third type of 6F6 in my stash, and that's the 6F6GA, and you can see the difference. Here's the 6F6G, this is the GA, and an order of appearance as far as historically, this would have come first, this one second, and then this one third, probably along in about the 50s. But there are your three styles of 6F6. They're basically just like the 6V6s. You'll find 6V6s in all three of these sort of varieties too. But not quite like this one. This one is a 6F6 GA, and I don't know if I've seen a 6V6 GA. So this will be interesting. Let's pop this in and see what it sounds like. I'm just going to pop it right in here, fire it up, and we'll try to do this without any edits. And if we see sparks, it might make for an interesting climax to the video. Well, we definitely got something going here. A little bit noisier. Let's check it out. Again, I didn't tune my damn guitar before this, but please take that with a grain of salt. I know I'm an idiot for not doing that, but I just like to grab things, and I guess it's the it's probably the Gen Xer in me. Wants everything now, the microwave generation. That has a really nice sweet tone, actually. Of the three 6F6s that I've tried, this GA definitely has a very sweet tone. I'm trying to determine whether or not it has any kind of red plating or anything because of the excess bias. absolutely fantastic. And just for giggles, one more time, let's pop the original 6v6 back in it and check that A-B back these to the 6v6 again. Position. Here's the neck position on the telly. And one more time, the 6F6GA. Neck pickup. Okay, and finally, just because it's been a while since I've seen anything really blow up and start making smoke, and I'm kind of itching to catch something like that on video, I'm going to try a 6W6 GT. And if you'll recall, the 6W6 on our chart was pretty close in plate volts, pretty close in plate dissipation, had a higher maximum plate current, higher transconductance, but where it falls down is the maximum screen voltage. We're going to put this thing in there anyway, fire it up and see if the screen just melts down or what the hell happens. We'll see. Maybe it'll cause a fire. Not likely, but let's fire it up and see what happens. It may kill the tube in quick order. It's definitely got a real nice bright filament. You see that? Now let's see what it sounds like for as long as we can get it to make sound. But anyway, yeah, it sounds pretty good. While it's lasting, if you wanted to use a 6W6, you certainly can, but you'll have to do a modification probably on your amplifier to get your screen voltage down. But if you want to try to use 6W6, there's a lot of them out there. I'm sure I've got several here that would probably sound pretty great if you were to get everything set up right. But anyway, that's a 6W6. Okay, because I'm a bit of a liar and glutton for punishment, and I still really want to see one of these tubes flame out, we're going to try a 6K6 now in this little amp. The 6K6, if we'll recall, had 215 volts maximum on the plate, 8.5 watts plate dissipation, so that's pretty low, and we're really pushing it without rebiasing this amp. 33 milliamps maximum plate current, so we may even start to see this plate glow. 2300 on transconductance, and at least we have 285 on the volts, which is closer to the 6V6 than the 6W6 was. So if the 6W6 didn't blow its top, I doubt this one will either, at least no longer than we're going to be playing it. Now, if we left it running for a while, it would probably start to get real hot and burn the tube up. But and I don't expect any of these replacement tubes to last as long as the 6V6 if you don't do some bias adjustments and so forth. But let's fire it up and see what happens. And I'm not bringing these up on the variac or anything. I'm just hitting the switch and just cross fingers. We have filament glow on this one. Let's see what it does. All right, we'll start off on the bridge. Definitely not as much volume or gain on this tube. You can tell it's got a lower plate dissipation maximum. Alright, thanks for sticking around and watching this video on the 6V6 family of tubes. A couple conclusions that we've reached. The 6F6 and the 6EZ5 are probably the best direct substitutions. If you didn't want to absolutely have to rebias your amp. If you want to do a little biasing and modifications, other good options are the 6W6, the 6K6, and those would be your best two alternatives besides the EZ5 and the 6F6. So again, hope you've enjoyed this video. Please subscribe down below here for more videos like this in the future, and y'all take care.